Very quickly, we'll move on to Marcos van der Hoven. He's the co-founder and managing director of Mass Timber Technologies, a company that has grown to be a leader in the design and manufacture of mass timber in Africa. Mass Timber Technologies aims to be a thought leader in the construction industry with a core focus on the development of sustainable construction practices.
We just lose her there. Can you guys hear me at least on my side? Okay, cool.
Yes.
Yeah, for the sake of time, I'm gonna jump into the presentation. I was asked to just maybe give. Oh, sorry, we're back.
Thank you very much, Marcos. You are welcome.
It's my pleasure. Thank you so much for having me. Yes, you just faded out for a minute, but you're back now, so I'll jump in. Okay. So yeah, I was given the opportunity to just give you guys a bit of an indication and a bit of a show and a tell of what we're doing at Mass Timber Technologies in South Africa. We are a company that's been around for around 2 years in terms of us putting the concept together and raising the required funding to create a South African mass timber company, something that isn't very normal inside of the African building context, and oftentimes is a very high barrier of entry due to the cost of machinery and techniques that aren't typically taught in the African building context. So we've managed to design over the last 2 years and implement a factory which is now in full production, capable of producing currently around 300 cubic meters of timber per month, of mass timber per month. And we're growing that up to around 1,000 cubic meters per month inside of the next 6 months. So it's been quite a wild journey, and I'd like to run through a couple of different elements to what it takes to set up a company like this. Some of the thoughts, things you have to think about in terms of how the material works, the technology that's required to access a better design flow, and then obviously how we also attack sustainability as a larger question. So inside of this presentation, you'll see that there's really 3 big things that we have as a manifesto as the company. The first thing is our agenda around circularity as the means to reach sustainability. And this concept is really just, and Oriel's kind of pointed to a lot of these things, but circularity in our mind is just the process of the material being grown, used as a building material, and then its ability to actually enter the earth again in a circular process, and thereby that carbon loop is closed. The other elements that we want to really focus on is the concept of design for manufacture and assembly, where we use the skills and technology available in 2023 to really solve all of the building design issues in a digital space rather than on site. And of course, the ability for mass timber, especially a material that we are learning about and we are bringing into a new context, to scale and be flexible enough to engage with many different building problems inside of the construction environment. Some of these techniques require us to really engage with some more advanced techniques of manufacturing, so a lot of CNC cutting, and obviously the integration of the project team in a digital space. But it allows us to really create a material which, unlike anything before, can kind of solve multiple building problems at one time. So, for example, if you use a CLT slab as a floor slab, you can also use it as a ceiling in certain instances. And for us, we're looking at a material that may be a little bit more expensive as an entry point compared to things like concrete and steel, which are prolific inside of the African context. We need to be able to start thinking a little bit out of the box to make this material better, and we need to be able to convince the project teams and the way that the projects get programmed to allow this material to become more relevant in the building environment on a commercial scale, at least. So there's 3 main themes that we'll talk about today. Is the tools that we have developed for hybrid construction, and I'll touch on the concept of hybrid construction in a minute. Obviously, what we're doing in terms of development inside of the African space, and then towards some problem-solving techniques that we've managed to put together in research to help perhaps start immediately with some projects that might be out there. So certainly, we're all aware that there's a massive climate issue at this point, and as building professionals, we need to be aware of the fact that our industry is responsible for the majority of our issues, especially when it comes to CO2. Cement and steel fabrication are the biggest, what do you call it, the biggest contributors to this space. And what we're trying to do is very quickly find a way to replace some of these primary structural elements like steel and concrete inside of the building environment to try and make a bigger impact on how climate change is developing. This is a big problem at this stage because it's not like we can just stop building tomorrow and just sit back and relax and just not use concrete. We're expecting a massive boom in population, specifically in places like Africa. So the requirement for housing, the requirement for floor area and offices and infrastructural development is growing at a rate where we need to be ready with our skills and our abilities to actually solve the problem, rather than contribute it. And you've seen in many different instances, and specifically in South Africa, we've signed up to a pledge at this point, but it's slowly but surely becoming legislation where new buildings by 2030 need to operate at net zero carbon. And this is a big ask for the construction environment at this stage. And it's a big question, especially when you look at the structure, how we're going to solve this problem. And we believe from our side that it comes through in the form of mass timber. So the big move that we're trying to make is stepping away from extracting carbon out of the earth and releasing it into the environment, but rather sequester it and keep it locked away inside of buildings. And maybe not turn it into firewood or chips where there's no value. So CLT for us, again, just as a basic concept, we're adhering solid structural timber members into a large slab to use as a structural element inside of a building. You have many different forms, and we'll touch on some of those forms, and Oriel's also spoken about some of them. But what we're trying to do is, with mass timber and general lamination of timber, is we're trying to create a predictable engineering curve for an engineer to be able to understand what the structural capability of this building is and do the mathematics around how that structure works. Because timber is an organic material and there's different stresses and abilities to deal with stress on an individual plank. By laminating it together, we can create a homogeneous structural profile across that panel, and we can start predicting how it's going to operate. The same thing goes for the way it deals with fire. Same thing goes for, obviously, how all these elements come together. It's all about making timber, which is organic, predictable. And we've seen some really impressive structures come together. This is another manufacturer in Cape Town who I believe speaking in a couple of weeks. They've constructed some large facade elements in Cape Town already, and we see how this work is becoming more relevant in a commercial sense, where it's going to start making a bigger impact. And certainly, you know, we're also not just doing this because of the environment. I mean, it's obviously a big player, but ultimately this industry growing in Africa represents a very large value proposition for Africa as a building context as well. Very often we see that our material is mined out of the ground, it's sent away to China to be turned into steel, and we buy it back at a premium, paying dollars for it. So what we're trying to see happen here is the ability for us to, in a very big industry in our continent, is to localize our entire value chain. So from the guys growing it in the ground, the people sawmilling it, the people manufacturing and designing, and then the builders, we can actually contextualize that material completely to a region, which obviously helps with everything from shipping and logistics costs, and certainly the value that we can contain and maintain inside of our local context. So we've been manufacturing some pretty large elements at MTT right now. We've kind of taken a very big step, and since November, we've been operating and producing at a massive pace with larger and larger buildings coming together, everything from small residential projects up to a 4-story high building, which is currently being shipped to Zanzibar for construction in a couple of months, which we're very excited to see. And it's all constructed out of 2 basic principles that we're focusing on. CLT, which is what we use to create floors, walls, and roof structures. And then the GLT components, which is simply just laminated in one direction and not cross-laminated, so that the performance of the fibers works in one direction, which is very good for columns and beams. So by bringing those 2 elements together, we can actually start solving an entire building problem rather than necessarily just doing small bits here and there. We've done all the relevant testing on our local material, which is obviously SA pine. It's various different species, which I won't get into right now, but from multiple different contexts, we've managed to do the stress testing. And with the certification body in our local context in South Africa, there's actually a building code relating to our material now, which we comply to. So these are very big steps, especially in South Africa, that we've made towards making this material more accessible. So we have a design guide online, which I would invite you to design, and I'll put the link in the chat a little bit later now, which is basically a breakdown of all the different elements of performance that we can leverage with timber. So the fact that it's got high specific strength means that we can do X, Y, and Z with it. It's lightweight. You can design for disassembly if the building needs to move at a later stage. And obviously concepts like rapid prefabrication can really push the thing forward. And I don't have enough time to go through all of them, but in the design guide, we've got all of that laid out for you, and I'd invite you to go read that and understand what our material grown in Africa is actually capable of doing, because it's very impressive. We've also got a lot of work behind us, which is really the software element to actually help us integrate all of this into our systems. And this runs all the way through from being able to integrate with how an architect thinks and then turn it into a digital set of information that we can then access as manufacturers, and then the builder can use. And like Oriel said, it's trying to turn it into a kid's plaything where it's like a Lego assembly kit with a set of instructions, which makes a simple process of installation on site possible. So obviously we've done a lot of different coding. We've managed to set up a whole bunch of different robotic techniques to actually fabricate this, which means that 99% of the building is actually created inside of a factory, in factory conditions, very accurate. And that means no waste on site, a very small labor contingent on site, no mistakes on site. And when you start adding all of these things up together, you'll see how effective the mass timber system can actually be. And what we're trying to do is basically pull the construction environment out of a terrible hole that it's sitting in, and using information technology and advanced manufacture, we can start creating a more effective and efficient way to build. So again, our design guide, please go take a look at it. Most of the information, everything from species all the way to stress grading and helping you understand how to design with it, is contained in there, and it's free, and you can just download it at your leisure. Again, I won't go into this because Oriel's already spoken about a little bit, but we've done the tests on the actual timber structural properties. So here you can access exactly what the strength is, and you can start allocating it to engineering values. So as an architect, you can immediately go and step into this without an engineer yet. You have to have an engineer later, but you could start defining your grid sizes and understand exactly how you can rationally design this building, how the fire rating works, how thick your panels need to be to deal with fire. And I'll touch on fire in a minute, but yeah, the tools are there now. We've done the research for you and it's available. So there's no more excuse not to be able to use this material in your project. So ultimately, what we're trying to do is make the difficult process of planning a building exist inside of a digital space. That's the core thing that I want to kind of drive home, is our ability to design with CLT inside of a digital space is where projects become really efficient. And what we're trying to do is take all these different components, because there's a lot of them when you build with this technology, and turn them into data that can then be very easily understood on a building site. And we'll show you an example of this quickly. Here's a house that we've just completed in Johannesburg. It's a designer sitting in Durban, it's an engineer sitting in Cape Town, us in Johannesburg, and none of us were actually in the room at all when we did this project. And the entire project got to site with a contractor that's never used CLT before. So we simply worked with the engineer to work out exactly the different connections and the different screw placements and the thicknesses of the panels. And once we went through all of that, we could create a digital twin of our building that the engineer and the architect could both sign off of, and the working drawings could be created by our system. And then the contractor could very easily assemble this. And what that is allowed for is the fact that a contractor who's never used this material before could, within 1 day of using this material, we did a quick mock-up in our factory using our gantry crane. He could get this building constructed to this stage here, him and 3 other people with a bunch of screwdrivers and the right techniques. And what we've managed to do is create a very easy system, which made it very easy for the client to accept this material as well. So they had to take a section of the client's roof off, and day 1 was removing the roof. And by the end of that week, the building was actually in place and ready to be cladded. I've just got a quick video here, which will just basically show you exactly how the site looks on this client's house as well. And you'll see there's no wheelbarrows, there's no cement, there's no water, there's no damage. This is a very effective way to build. It's a healthy way to build. The contractors like it because they end up being cleaner once they go home than when they arrive to site. And it's a fundamental thought process that we in the construction environment need to change our minds about when we look at a building site. So yes, by the end of that week, the building was weather tight and ready to accept cladding, and actually got completed. The building was done, I think, in 2 weeks. This whole construction process was finished. So they had the full European spec. The client was quite keen to do the whole shebang. So they've actually insulated and cladded on both internal and external faces, surface mounted all of the conduiting. And it was a very effective process, a very easy way to build because there's no cutting and welding and difficult materials on site. It's just screw in and there you go. We're also able to build with this material in very remote places. So here we did a project just outside of Drakensberg. This building got built in 5 days as well. It's a little bit less, like a lower spec of construction, but the ability for us to go to places where you don't need water or advanced technology or big contractors, you just arrive with a crane in a system that has been worked out all on the front end so that when you get there, it's ready to go. This is how you make this material very effective. So right now, one of the more exciting developments we're working on is the Shape project, which Leander will also mention. He's the architect on this project. It's a 4-story high development on Zanzibar Island. And this project as well was designed with an architect operating out of New York some days, and Kenya some days, and the Netherlands some days, engineers in Germany, fire engineers in Germany as well, and the client in Zanzibar. It's a global project, but ultimately our team of 4 people were able to unpack this project by using building information modeling to contain all that information. It's quite an advanced way of thinking in terms of being able to actually use the full potential of our design software. But once we get it right, it's so easy to understand, and there's so few mistakes that are able to happen. So we can define the components of the building very effectively and create an environment that mistakes and waste don't happen on site. So we can actually containerize an entire 4-story high building inside of 4 containers and send them, and it still works out in terms of a very sort of acceptable budget if you compare to other materials as well. So, for us to be able to break down that building into all the different joinery techniques that are required for us to then machine, I mean, it's very important that this information gets understood by all the parties involved. But then for us to go and access 1,091 total timber parts, and 165 of them are unique. Again, it's a mind shift that we have to work away from, where you typically go to a building site and go pack bricks and then you're done. But here we have to actually do all of that thinking on the front end, and that's what makes this material work so fast on site. And that's where we win in terms of how the costing and the pricing works. We have some very interesting technology that we're developing, which is like generative design algorithms that help us work the most effective panel sizes once we have all of the designs together. But I won't get too deep into this. But it is about us being able to, in an African context, we're all South Africans. There's no fancy German technology here. It's just our own minds and our access to the internet and research. We can actually make sure that we're kind of on the leading edge of material thinking and computer generated work as well. So yeah, it's this is what a 4-story high building looks like, flat pack, like a piece of IKEA furniture. So yeah, it was a very fun project for us to work on. Inside of our design guide, we've also actually listed out all of the different details, which we've taken from the European context, and we've kind of rationalized them more for a South African system. So you can look at this and you can start understanding that maybe we don't have to build our walls so thick, but we can actually access the material a bit easier and make it more effective for our local context with different climatic requirements as well. So I'll leave you with one more thing to think about, and it's just really a thought process. We're trying to move from the left to the right here, from high concrete use all the way through to total mass timber. Obviously, we have to be very, we have to think about the process of consuming too much timber. It's another thing that, Oriel touched on. It is a resource that we have to maintain. So we find that for the time being right now, the early steps, especially in Africa, is for us to hybridize these systems. Make sure that a client is still feeling confident with his construction process due to the fact that there's a technique that he's familiar with. And we limit maybe to 30% of the building product to be hybrid mass timber right now. So a low piece of hanging fruit for us to look at is the floor slabs of a high-rise building, where 80% typically of your building's weight exists in the floor slab. So what we found with this is that, sure, we can have a contractor feel confident in his structural frame, And we can use the ability of CLT to act as a diaphragm, but also start limiting the amount of concrete that they use, especially if it's such a large target for us to look at. So this way we can actually lighten the foundation load. It's much less intensive earthworks, much less concrete required in the foundations, and we can leverage a lot of speed to get this building up a lot faster because we're in a prefabricated system. So we like this system here. This is part of the Shea building. It's a TCC. It's a sort of a timber concrete or CLT timber concrete hybrid slab, where we really help with some of the problems with CLT, like fire and acoustics, especially when you work into higher rise buildings where you need a very high fire rating. This is a system where we can actually reduce the concrete by about, I think it was on our one project, about 70%, but you still have the benefit of concrete working in action with that timber, and obviously solving a lot of the problems that come with timber construction as well. Here's a typical detail of what the floor slab might look like. This gray area that's hatched here in the center represents the sort of charring layer of CLT. So on this building specifically, we needed a 2-hour fire rating for the floor slab. It's very difficult to do with CLT alone, but due to the fact that we could actually use this concrete hybrid slab, we can play with the positioning of the rebar and the thickness of the concrete, and then also some of the coverings that are required on different elements of the floor slab, and we could achieve a 2-hour fire rating with this. And this is just sort of a breakdown of exactly how that system comes together. So when you look at the system all come together, you have basically your precast concrete floor slab, concrete columns and beams, a timber laminated beam in the center, our floor slabs come in, and on top of that, you throw in a concrete surface slab. It's also a really nice thing for developers who don't want to worry about the timber floor or a very complex build-up of floors. They could just go tile on top of this thing and works the same as what everybody's used to. And this is where we see a huge potential for us in the environment. So for this specific example, this was an 11-story high tower that we were working on. The reduction in weight of this building was represented at about 70%, which means that we could actually not only sequester 2,000 tons of carbon inside of the floor slabs, but we could also reduce the concrete usage after the fact as well. So we're actually stopping concrete being poured, which is quite an interesting exercise to think about. And ultimately, what we're able to do is reduce the construction time, and in this case, it was about 40% of the construction time. So what that does then is, if you look at the whole project scope, sure, the CLT may present itself as a more expensive material, but once you start looking at the impact on your foundation, your time, how propping and formwork might work on the construction side, 28 days of drying times, all of that combined together, we could actually start being on par with the conventional build. And I'll skip this one. It's fine. I know I'm on my limits here, but this is the last slide. So the big point we wanted to make is that we just want to see how we could potentially look at changing the way that the construction thought process works, where instead of planning the building towards the end of the construction cycle, we push that planning to the start. And that way we're going to actually be able to save money in terms of our design process to then spend on timber, which I think is an interesting way to do it. I'll leave some thoughts for you here. I won't go through all of them, but thank you very much for having me. And if anybody has any questions, please drop me an email and I'll happily answer it for you. There's a lot to get through in the 20 minutes. Okay, cool. I'm done. Thank you very much.
Thank you, Marcus. You overrun your time by 5 minutes, but that's okay. Very, very educating, and yes, you really spoke a lot at the end. So you have several questions that would take you into the question and answer period. And very quickly, if Moradeke and Hilton will have anything to say in summary, maybe 1 minute each, or either or both, and so we can move on to the other movies. Thank you.
Okay. Yes, thank you. Marcus said quite a bit. He actually introduced his company that already manufactures mass timber for construction. He did highlight what the principles that they work with, which particularly is circularity in the process. So they move all the way from the growth to design through manufacture and assembly. That is, they take care of timber right from through the complete value chain. He did talk about the fact that they have used technology in a lot of in a collaborative way to work. That is, they use building information modeling to work among the players, that's the designers, the manufacturers, and even with the assembly. And he did mention that true, mass timber construction might be expensive at first, but by the time that it is weighed alongside the amount of time that it is saving and the amount of materials it's saving, as well as CO2 that can be sequestered from the environment, that it begins to make sense. He did say that he did present, he made his presentation, on mass timber as a tool for hybrid construction, the development of mass timber in Africa, and mass timber construction in Africa. Well, he mentioned the fact that there are a lot of opportunities in Africa right now because Africa is expected to consume a lot of building and infrastructure in the near future. According to him, cross-laminated timber is like making timber more predictable in use. Yes. Hello.
Yes. And can we move to factory?
Can you hear me?
Okay. Please, you need to hurry up. Please speak a bit faster and louder so that we can move on. And we still have the end.
Okay. Okay. I'm mostly done, with what I was able to glean from what he said. So CLT is often used for floors, walls, roofs, while they use GLT for columns and beams. So they use this together. They have developed, a design guide, and they respond to the building code already in South Africa. They do some testing as well, and he's just encouraging that this type of construction is good for precision assembly and can be very useful in even budget projects. Of course, he did advise that to start with, we might be thinking of a hybrid kind of process rather than shocking the system, moving all the way from concrete to mass timber. Thank you.
Yes, thank you, Akmo. So I'll just jump in quickly and just pick virtual points I picked out from Marcus's presentation. So Marcus introduced his company, Mass Timber Technologies, and he mentioned that they design and manufacture and also assemble mass timber. He also spoke about the skill and flexibility in design. He spoke about their machinery systems and their CNC cutting prefabrication systems that they use in manufacturing of large woods. He said their factories, of course, is integrated with the BIM, which is the Building Information Modeling System. He's encouraged that in Africa, we should move away from cement, from concrete, and move to timber, thereby bringing us to fabrication of large-scale slabs for construction. He said timber is good for structural elements in construction, and because timber is predictable, we can make it what exactly we want when it comes to construction. He stated that the cross-laminated timber and the glued laminated timber, that's the CLC and GLC, are major elements that they use in construction all over the world. He said that timber, they do the material testing for timber, give them structural safety and production auditing, all that they do as they proceed in meeting up with their demands and with whatever timber products that they are working on. He showed us a few projects that the company is working on right now. Told us majorly timber is to eliminate, they advocate for timber to eliminate climate issues, which I think
timber really sure.
And to help in the CO2 emissions to support global change. Majorly, he spoke about their building codes that they follow in the construction and production of the timber elements. Thank you very much. I hope that reminds us a little of, okay, before I go, just the last one, he said there is a 40% reduction in construction time when you use timber as your major construction element, and a 70% reduction in weight when it's being compared to concrete and other construction elements. So basically, Marcus is sending and trying to tell us that wood is a preferred material for construction, and that's what they do basically in their company. Thank you very much.